Welcome to today's class. We are going to start with the theory of computation, and our very first chapter will be the introduction. And later, day by day, we'll gradually discuss all other topics. Good morning, everyone. Today, we are going to start a new chapter, theory of computation, or computational theory. In some colleges, it is commonly introduced as. We have this topic, this subject in our GATE syllabus, and it contributes most of the marks that is being or the most of the questions that is being asked in the gate. So starting with the very first thing, that is we are having the languages are just a set of strings following some rules over the alphabet. So if I'll try to just write over some alphabet, you must be aware what alphabet is. Alphabet is just nothing, sigma. Let's say if we'll take an example here. So we are having this alphabet of containing 0 and 1 inside it. So let's say we are we are writing a language of let's say some automata we are having. We'll talk about the automata in later part of this video only. So basically, let's say we are finding a set of all strings that could be generated over this alphabet. So we can write it like this: w is just a sigma star, or simply we can say we are having a set of alphabets with the closure. A star is simply a closure we call in ToC. So basically, closure of alphabets can be expanded as these all strings. So the very next thing we are having is the types of the languages. Types of the languages we are having is this. We are having 6 kind of languages. First is regular languages. Second is the deterministic context-free language, DCFL. And third one is the context-free language. Fourth is the context-sensitive language. Fifth is the recursive language. Sixth one is the recursive enumerable language we are having. So these different kind of languages are being accepted by different kind of machines, and we have an infinite number of languages in our current language system, and we can simply we have categorized into in 6 different categories. These are the topics we have to cover in our university exams or inside the gate as well. Now the very next topic we are having is the automata. Automata is just a machine that accepts or recognize or generate some output on the basis of what we have provided as an input. It is very similar concept as we do in our computer programming. Let's say you write a program, and you provide some input on that. On the basis of that input, what you have coded and what you have given instructions to the computer will do some operations, and either it will give an boolean result, or it will say like we have accepted the input, or simply can generate some output on the basis of what is the input we have provided. On the basis of that, we have divided our automata as well into 2 different categories, that is a recognizer or an acceptor, or we can simply call it as a different category as a generator. Generator is also an enumerator, or we can call it as a transducer because we are transducing the output on the basis of input we are providing. Now we are having a different kind of automata, and the very first is the finite automata, FA. Second is the PDA, push down automata. Third one is the linear bound automata, and fourth is the Turing machine we are having. When talking about the syllabus, around 70% of the syllabus of ToC at GATE or university are covered by finite automata. Rest 30% are from these 3 different kind of machines, automata machines. So the language accepted by the finite automata is the regular language. The language accepted by PDA is the context-free language. Similarly, we are having context-sensitive language accepted by LBA, linear bound automata, and the fourth language we are having recursive enumerable language that is being accepted by the Turing machine. Now talking about the machines we are having, uh, starting with the finite automata. So we can further subclassify this finite automata into three different categories on the basis of the recognizing capacity it have. So we are having DFA, NFA, and epsilon NFA. These all three kind of finite automata is used to recognize or accept some language. Let me just write the full form so that you can simply note it down. And similarly, we are having the epsilon NFA, and epsilon NFA is exactly similar to NFA, but we can have a transaction from one state to another state with the epsilon. Epsilon is just like you can transition from one state to another state without having any input. The power of DFA, NFA, and epsilon NFA is exactly same. So basically, what do I mean by power? Power is basically used term to determine the set of languages that is being accepted by different kind of machines. So we can simply say the language accepted by DFA is exactly similar to the language accepted by NFA, and similarly we can say that the language accepted by epsilon NFA is exactly similar to what we have discussed as a DFA or NFA. We will see the proof of it in some later classes, but you can simply note it down as of now. And we can also, one more thing, like we can do a conversion between NFA and DFA. If we are having the NFA or epsilon NFA, we can convert it back to NFA, or correspondingly we can convert it to DFA. That's not an issue. And similarly, for PDA, we are having two different kind of PDAs, that is deterministic PDA and simply PDA. PDA is just a non-deterministic push down automata. And the language accepted by the PDA is it can accept both kind of languages, like non-deterministic context-free language or context-free language. So it accepts all kind of context-free languages, but this deterministic push down automata can only accept deterministic context-free language. So this is all for today's lecture. I think we can review what we have discussed today. So the very first topic we have discussed is the languages. We discussed the types of languages we are having. We are having 6 different kind of languages. And then we discussed about automata. Automata is a machine that accepts or recognizes a language or generates output on the basis of input you have provided. And broadly it is classified into 2 different categories based on that only. And now we are having 4 different kind of automata in our syllabus. The very first is the finite automata, second is the push down automata, third one is the linear bound automata, and fourth one is the Turing machine. We are now having a different kind of languages accepted by different kind of automata. Regular languages is accepted by finite automata, context free languages is accepted by PDA, context sensitive language is accepted by LBA, and similarly recursive enumerable language is accepted by Turing machine. Now we are having subcategories of finite automata, that is DFA, NFA, and epsilon NFA. We'll talk about Mire and Mole machines at later point of time. That is not important right now. We'll discuss in some other video. And we also discussed the language accepted by these 3 different kind of finite automata is exactly same. Now we are having push down automata. Push down automata is also of 2 different categories, DPDA and PDA. The language accepted by PDA is context free language, and DPDA is deterministic context free language. So let's wrap up here. Thank you for joining today.